Testing microphone.
Hey.
Good morning.
Hello.
Good morning, dobré ráno, příjemné dopoledne.
Dobré ráno.
Dobré ráno.
Dobré ráno. Tak, standardní otázka, je všechno v pořádku? Má někdo nějaké otázky na mne? Pokud ne, tak jedna informace. Jak jsem vám zmínil pondělí ráno, ta informace patří pro účastníky kurzu. Tak v pátek před začátkem 5. dne kurzu jsem vás informoval, že plánuji organizovat půlhodinovou aktivitu nebo půlhodinový webinář. Jediný téma je Q&A webinář, jak se registrovat na zkoušku a jaký bude průběh zkoušky. Před chvíli jsem vám zaslal pozvánku se separátním linkem na separátní Teams session, takže prosím vás, kdo může, tak se připojte v 8:30 a máme 25 minut na to, abych vám prezentoval, jak to bude probíhat, pak vaše otázky. Nebudeme se bavit o tom, co je obsahem kurzu, ale budeme se bavit o tom, jaký je proces toho registrovat se a jaký je průběh zkoušky. Děkuji vám. Peter, I just informed that I sent invitation to all students to webinar focusing on what is the process of CEH exam scheduling and how it looks like. I mean, exam portal and administration and questionnaire and so on. So you are welcome, and I sent the invitation to you as well. But please be informed that, or take into account that it will be delivered in Czech language. So another opportunity to to listen Czech language for you. But yes, as it is focused on student, not on you. Yes. So that's all from my side. So wish you productive 4th day of the training.
Yeah.
So see you later.
See you.
Thank you.
Thank you. See you.
Well, yesterday we stopped this sniffing RGP. We began sniffing POP passwords, then SMTP messages, then HTTP form-based authentication. Basically, it's not about authentication only. You just simply can sniff all the conversations. Like if somebody orders pizza over HTTP, you could figure out not only like password, but also the mobile phone, physical address of the victim, which is designed for like pizza delivery boy. We also have sniffed RDP session. Let me explain a little bit the idea of this, why it was successful. Because RDP version 4 is encrypted with well-known key, and this key is published on Microsoft Developers Network. To mitigate this issue, what you need to do, say you go to the main controller, just for instance, you check RDP properties, make sure to enable network level authentication. One of possible mitigations. So beginning Windows Vista, it's enabled, so you need to make sure it works. Well, because I saw it many times that some admins switch to compatible but less secure mode because their clients do not cannot support this mode. This is bad idea. Or say clients are working in compatibility mode, server incompatibility mode, and this is it. So in case someone is sniffing, you never know. Or say you could implement IPsec encryption, certificates, and so on. But anyway, this should be a must. This is a must. And what happens if somebody attacks the network, but network level authentication is enabled? So let me check it once again. So I am enabling NLA. I'm attacking from attacker machine. Go. And the victim server. Yeah, I'm sniffing between different victims. Sorry. Let me double check once again. So I'm spoofing between 7 and 8. Yeah. So I'm going, for example, to Windows 7 and configure RGP with NLA. Yes. Now connecting from Windows 8 to CEHv13. It tells me that identity of remote computer can be verified. This is the first warning. You need to pay attention to this. And then it says the remote computer requires NLA, but you do not support, which is definitely the, say, digital signature of attack. Well, it's done with RGP. Again, any questions about this part of sniffing? If not, we go to the next part. I'd like to try sniffing SMB. It's not guaranteed to work in virtual environment, so I would give it a try. I need some computer with, yeah, I need some schema. I need some computer with .NET 4 running network miner, you will see, and some SMB server and SMB workstation. This is going to be my SMB workstation. One of this should be SMB server, and the another machine will be attacker, such as this one, the attacker. So let me try. I will try running network miner on some of these machines, maybe on 2012. I will try. So on web server, which is not web, but attacker machine at the moment, I'm going to Peter Tools. Peter Tools packet capture, network miner. Basically, I will drop network miner to the desktop. Let me try if it works. Oh, new version 3.3.0. That's new to me. I have not tried yet. Okay, so at least it's running. Good. On top of this, not on top of this, this will run on top of Kane. So I will also install Kane on the same machine. So Imperial Tools packet capture, Kane, go. So I need to perform man-in-the-middle attack. And on top of this, I will run packet analyzer, such as network miner. That's the idea. Okay, so Kane is installed. Checking. I'm going to sniffer, hosts, network discovery. Yes, this one should be activated on this network. 10.20 to 12. Let me check. I know. Go. Yeah. Okay, so Kane is working on web server, and I have discovered few hosts. Well, in this picture, I will try to attack between 2016 and the router. So between two MAC addresses like here. Okay. So I'm going to APR, click white space plus the router and 216. Go. Go. On top of this, I will run network miner. So I'm selecting network card Intel desktop. It's npcap installed. Okay. Start. Well, now Windows 8. I will try to ping the web server first because it happens not to work. Ping 10.20 to 16 doesn't work. That's bad. Okay. Kane in that subnet kills something. I will stop sniffing and redesign the exercise. So I will move Windows 8 to this subnet. And we'll spoof between Windows 8 and 216 directly like this. So Windows 8, switching virtual machine to another subnet, to CEHv13. Okay. Checking network connectivity. Give me my IP address. Okay, 10.20.0.100. Need to rescan network in Kane on attacker machine. All right, so I have discovered two of my victims, 100 and 216. Not this one. Scanning between 100 and 216. Go. Checking network miner. Stop. Start once again. Checking if I can ping the web server. I do. Okay, good. Checking if I have routed packets. Yes, I do. So the exercise should be ready. So in this exercise, again, I have moved this PC to VMZ, and now this one is attacker machine, and it spoofs between two victims. All right. I need a file share on that machine. Let me check if I have some shares already. The only issue, I'm logged in as Haxor. I will switch user to admin, just to have single sign-on. Because the purpose of exercise is sniffing SMB, not hacking passwords. So I'm going to 10.20.02.16 to the C drive, for instance. I see some data in here. Network miner already has an idea of something. What's going on in the traffic? What's in data folder? Let me create new file, such as salaries text, and save some data. Manager 1000, sales 2000, IT 3000. Save. Have you noticed? I said save, I saved the file, and this file appeared on attacker machine. Let me arrange virtual machines. Maybe you don't get it completely. So this is file server. It contains documents such as this disk. This is SMB client. It navigates to file server shares. And there is man in the middle sniffing this conversation. So when victim has saved data to a file server, an attacker has sniffed the file. So you see the conversation between 100 and 216 with SMB2 protocol. Let me check this file. It is that file. So could you please tell me if victim is aware that somebody is sniffing the network? Victim is not aware. Yeah. So victim saves files on a share, and this is it. Credentials are encrypted, and credentials are delivered by using NTLM session security protocol. I don't expect to crack admin password. You could try, like if you go to Kane, possibly, maybe, I'm not sure. Yeah, I don't see those credentials here. I don't know why. This is another issue. So credentials are not sniffed for some reason, but file content, that's the hack value. I don't need your admin password or manager password or sales or anything. I need documents you work with. So I can save text documents. I can save Excel documents. Let me try Excel as well. I'm still sniffing. I'm still attacking. So this is victim, and this is the attacker. Network miner. I'm still here. I'm still working with my file server. Annual report. Like sales 100, income 200, save. Let me save it to my desktop, whatever, report Excel, and then I will copy paste this file to the share. And look at this, what happened. Report Excel document already appeared on attacker machine. I cannot open it because I don't have Excel installed. But trust me, this is totally sniffed Excel document. So what kind of documents I have sniffed? Microsoft Office. I have tried text, pictures, different kind of pictures such as JPG, PNG, and so on. PDFs. I have tested those files basically. So if I have some funny picture, say, let me check my cat, users, Hacksaw desktop, funny cat, copy, paste. As you might see, this traffic was immediately sniffed on attacker machine. What printing? I don't want any printing. So that's the picture sniffed from the traffic. So the SMB by default SMB settings are the subject to sniffing. And even though your account is protected with long, complex password, the data you save on file server is not protected. Typically, we work with home folders, such as I save my documents to file server. Typically, we also work with shared projects, salaries, reports, some sensitive business data, and so on. Everything could be sniffed, and nobody is aware. Now let me show you how to protect your system from this threat. So I really hope you understood how dangerous is this. Now, okay, I'm stopping sniffing, and what to do.
Peter, sorry,
Yeah.
does it work for all SMB versions?
Yes. Oh, I forgot one more thing. Let me close Miner. I want to show you Wireshark. Yes, the Wireshark. So on top of Kane, I will launch Wireshark so you can see how it works. And traffic, Wireshark. Go. Stop. Stop, stop, stop. That was wrong adapter. Ethernet. Go. Salaries. Text I'm opening. So I have navigated to SMB server and opened this file. Now I would like to find this file in traffic. Simply SMB. No, not SMB. Maybe somewhere here. Not SMTP, so not ARP. And not SNMP. Yes, so I'm checking traffic for clear text data. I will scroll through packets just to find out where I have opened this document. So I'm looking at this part at the moment and just simply scrolling through packets. There's browser announcements. Checking for salaries here. Salaries text. You see the file name, but you don't see the content. I want to show you the content of this file. Yes, there it goes. So this is how it looks like in traffic. So I hope you understand this. No need to sniff anymore. Now I'm going to configuration of SMB server. So my SMB server is this one. There are two methods what to do. with this issue. The first one is you go to Server Manager. Then you go to, okay, let it initialize. Then you go to File Storage Services. Then you go to Shares. And if you have some share, okay, you create new share, for instance, SMB, whatever, quick. Let me share some, whatever, C data with data name. Yes, okay. And look at this. There are two interesting options. This one is not about security, but it is. Access-based enumeration allows you to see only objects you have permissions to. If you don't have permission to read an object, so you will not see this object in traffic. Typically, it's used for home folders where every user has his own home folder. So let's name it home. And this is user 1, user 2, user 3, and everybody is connecting to share home. And then he only recognizes his own folder and nobody else's. And one more option is to share like projects. And you have accounting, sales, IT, production, something like this, with configured DACLs. And if access-based enumeration is enabled, you will only see projects you have access to. So this is a must, basically, for all the systems. And one more interesting option is this one, encrypt data access. So if you run SMB version 3, so you could enable built-in IPsec to encrypt this data. Okay. I will not customize permissions. I just simply am presenting you how to protect this specific share. My favorite option is a little bit different. So if you go to PowerShell, if you request SMB server configuration, you will see a lot of options of SMB. And one of those options is encrypt data. So if you configure like set SMB server configuration, let me do it just from here. Set SMB server configuration dash encrypt data true. Yes. Now all of the new connections to all the shares will be encrypted with IPsec. Let's check. First, I need to close all my current connections, and I will relog on totally to make sure I have ended all of my connections to this SMB server. Next, I will continue sniffing. So on web server, I run ERP spoofing. It will drop me one more error message. Okay, I see. So I'm spoofing at the moment. Poisoning. On top of this, run Wireshark. And now navigating to SMB3 share with enabled encryption. So it's totally transparent. You don't see it somewhere on the screen. But let's check it in Wireshark. In Wireshark, SMB2, this one. So this is how it looks like. It's not SMB2, it's SMB3, and which is encapsulated in the SMB2 headers. So what's inside, I don't know. So two hosts have synchronized keys and now perform SMB exchange with encrypted data. I cannot get in.
Can I ask you a question, Peter?
Go ahead.
I would like to ask you, is it possible to find out what version of SMB is running when I'm connecting to server without sniffing the traffic with Wireshark?
Sure.
Because I would like to know if the Samba if the server is secure or not, and if I can pass the information to the server or not, if I can find out somewhere in the Windows what version of Samba is used.
Let me check. Oh, if you talk about Windows, you just need to know that SMB version 3 is supported beginning Windows 8 and 2012. So this support is enabled beginning 2012. So if your question is like if the server is configured for SMB, so you need to forcibly request IPsec for SMB. That's the question. I don't know. Let me show you two things. First is GPEdit. So in group policy, you have plenty of SMB session configuration. In Windows settings, security settings, local policy, security options, there are a lot of SMB related, options. Like Microsoft Network Client basically is SMB client. Digital signature is not IPsec. That's not IPsec. But you may configure this to always enable and then read this article to understand the meaning of this digital signature on SMB packets. The idea is here that SMB packets could be replayed. You could sniff, for example, NTLM1 authentication and replay it without cracking. Something like pass the hash. You could also replay SMB packets. I'm not ready to show it. But, so if you set digital signature to enabled always, if you set SMB server to require signatures, you will improve the security of your SMB server. Also, it's good idea to check, let me see, this part. LAN manager authentication level tells you which network protocols are supported for NTLM authentication. For example, you could set the best option like only support NTLM version 2 and refuse NTLM. I'm not talking about LM anymore because it's way outdated, but this depends on company. So you could do this on all machines through all enterprise. So you could improve it here, here, and there. Then there are more options, for example, LDAP connections. This is a good question because you just cannot deny NTLM in peer-to-peer networks. In Active Directory, you could use Kerberos here, but not in non-domain networks. And basically, that's the very beginning where you can look. The second, and yes, for example, DAP server signing, you could read about it, what is this, and how it works. And the second option, we will take it maybe in an hour. We will configure IPsec group policy. Not just simply enable for SMB, but for all connections. So you will see maybe this is the good choice for you. Okay, so this is done for SMB. And we go to the next exercise of sniffing. Let me check. Yeah, probably we would like to move to Kali and check a few exercises with Kali. Please make sure to stop all sniffing on all Windows machines. You cannot sniff on multiple hosts simultaneously. Even though, let me give you one recommendation. I will show you in seconds. I just want to close everything on this attacker machine. Okay, this is good. I'm switching Windows 8 back to LAN network. Okay. And now I'm switching to attacker machine just to show you what to do when you're very new to some network. Now I understand why my attack was not working. You see, an attacker has ERP spoofing activated. That's why I was unable. That's why I was unable to sniff here, because sniffing was already running here. So again, I'm stopping all the sniffing and removing this. So when you first connect to the new network, you just simply have connected your attacker machine to the network and scanned for hosts. Now you know how many hosts are there in the network. So you go into hosts and you know all the hosts. And the question is, what to scan, what to sniff? What could be the good direction of sniffing? Let me explain two ideas. If you have discovered all the hosts, if you have scanned all the ports, so first, host discovery. Second, port discovery, port scanning. Now you know who is the server, who is the workstation. Now you know that this is the router, this is the domain controller, and those are clients. Obviously, if you begin sniffing between two clients, there is no reason for this, because in many cases, clients do not communicate. They communicate with servers. So it's a good idea to begin sniffing from server. You could do it like this. On attacker machine, you know that this one is Active Directory server. You go to APR plus, select the server and everybody else. Basically, you don't need everybody. You don't need to sniff your Kali. You select several clients like this. So because this is the server and those are multiple clients. Could be the router as well, but I suggest just simply server and clients. And then by poisoning, you will see how many packets are routed. There is the problem. I've tried sniffing multiple machines and figured out that this kills the network. I've tried to sniff 100 machines. So a server and 100 machines, and the network just simply died. Nothing was working totally. But if you see how many packets are routed, you see the most, I'd say, most tasty target, most tasty client, which sends the most packets to server. One more idea is to sniff between the router and everybody else. So if you click here and select router and select the whole network, with the exception of maybe your Kali. And again, wait for packets and see how many machines interact with the router. Again, this will kill network, so you don't need to do this like for a long time. But when you see first packets, okay, I'm poisoning, and say I check email on the victim machine, and you see the first packets. Stop. That's enough. So I'm removing everybody else and continue sniffing on one target only. This will not kill your network. On top of this, I will run Wireshark. just to figure out how many unencrypted protocols are there. And that's the good starting point. So if you're stuck, you don't know what to do, try analyzing what's the most tasty target for you. So I have stopped all the Windows attacks. I'm not sniffing on any Windows, and now switching to Kali. In Kali, please open at least 3 tabs and form sudo su in every tab. So now I have 3 tabs, all sudo su. And tell me when ready.
I'm ready.
You're quick. You too.
Ready.
Nice. So we will use 2 tabs in here for ERP spoofing. Very simple ERP spoofing. The command syntax is arpspoof, and the interface other 0 in this case, and targets. So that's the question, what targets to select? In my example, you see I have tested between Windows 8 and the router. Why not? So on the first tab, I spoof between Windows 8 and router. On the second tab, I will spoof between the router and Windows 8. So reverse direction. Go. And the second tab, ARP spoof interface 0 and target 172.20.128. So the syntax is this one. So if it's running, you need to enable routing, because if you do not enable routing, packets will not be forwarded to the internet. I want to spoof communication between Windows 8 and the internet. That's my reason. So how to enable could be your Kali has this prompt. Could you please try and tell me if you have this prompt? Type sysctl and check if you have this prompt. Just simply use it. Yeah, you have it? Okay, good. So just simply press write and complete the sentence and execute. And we will continue attack from this window. So you don't stop ERP spoofing, let it continue in 2 tabs. In this tab, you have enabled routing, and let's do something such as I'd like to test driftnet dash interface add-on 0. If you don't have driftnet deployed, so you need to opt-get update, but I don't suggest I don't recommend you doing this right now. If you don't see it, so just simply watch and desist. And that's it, because it may take significant time. And the second is apt-get install package dsniff. So if you have dsniff installed, so driftnet is a part of this dsniff. Driftnet Ethernet 0. Go. So you have driftnet? Yes, no? Yes. Okay. And go full screen. This software sniffs pictures. On Windows 8, I'm going to Bing. To Bing.com. The reason is because Bing by default runs in unsecure HTTP, and hope I don't need to tell anything else. You see everything on your screen. Do you? So everything I'm binging is represented in driftnet. Does it work for you, please?
It works for me.
Thanks.
Yeah, it works.
It works. Thanks. So this is a short demo. No need to explain anything. So it just simply works. Good. I'm stopping driftnet. And let me check my checklist. Once again, you can have my checklist from my OneDrive just in case. But next, what I want to show you is a little bit more complicated stuff. It's called as strip SSL. The idea is that this is the SSL server, HTTPS server, or web server. This is the web client. When you navigate to HTTP something, such as HTTP Google.com, it responds back. I don't remember a specific code, just my fantasy, such as 403 moved permanently to HTTPS www.google.com. And then you establish the connection to HTTPS www.google.com. Very simple stuff. I suppose you know how it works. But you see the problem that attacker cannot sniff HTTPS because the certificate will become untrusted and users will be presented untrusted certificate and so on. But attacker can intercept this one, can intercept the first response. And how it works, the attacker, the man in the middle, is filtering traffic like this. And when response comes to attacker, moved permanently. Attacker accepts this, but never forwards to a client. And client knows nothing about this. So SSL session is actually established. But it's established between attacker and the web server. And then attacker unpacks this session and delivers pure HTTP to a victim. So attacker intercepts this message and never gives back to a client. Basically, you know what? I will stop ERP spoofing. Control C on both tabs, additional tabs. So it stopped. And I will use one more program, BetterCap. BetterCap, which could also be installed with apt-get install BetterCap. And then you can run BetterCap. If you have, you could try, but it's not guaranteed to work all the time. So let me show you an idea. So in BetterCap, I will have some configuration. First, let me check help and see what's running, what's not. Next, I will enable some modules. Set http.proxy and module submodule SSL strip on. True. So this value is true. Now I can launch HTTP proxy on. Next, I can launch network reconnaissance on. And I have detected host around. Okay, good. Next, sniffing. Net.sniff on. And on top of this, ERP spoofing. ERP spoof on. So step by step, I have configured proxy to perform SSL strip and enable HTTP proxy. On top of this, I have discovered the structure of the network. On top of this, I begin sniffing the network. And now I begin ERP spoofing to have proxy running on ERP spoofing and substitute packets with SSL strip. Go. Kind of simple, but now let me check if this works. On victim machine, I'm navigating to http SSLV. This is specific website, our local Latvian eBay, local Latvian Amazon. Typically, it has the redirection to SSL, so I'm checking if this works. Enter. And look at this. It's still HTTP. So you could surf like goods, but you see, I am on HTTP. What if I will do it from another computer, not attacked machine? So let me go to, say, web, Firefox, whatever, and I'm going to 3W, okay, HTTP, 3W, SSLV. And you see the difference. It moves to HTTPS. So this machine is under attack. This is not. Do you have BetterCap? Have you tried? Does it work?
Yeah.
Yes, it is. Okay, good. Right. Basically, that's it. Quite in here and in there. Not all the sites are vulnerable to this attack. Some websites have countermeasures such as HSTS enabled. So if you enable HSTS, so you will not be delivering content over HTTP, because the browser will know that HTTPS is required. So this is some tag injection in the HTML which instructs browser that HTTPS is required. Well, let me check if I have more exercises with sniffing. Yes, I have one more exercise. Let me show you one more syntax. Syntax of ettercap. That's not bettercap, but ettercap. Because the syntax is kind of complicated, non-typical one. That's why I would like you to know this. So you perform as an ERP spoofing like this. So you specify IP addresses with those slashes. And then on top of this, you could run, say, driftnet. This also works as ERP spoofing. Also, one more option is DNS spoof. But the issue is that for the latest Kali versions, it doesn't work anymore because the injection, which is performed by DNS spoofing, is too late. It's too delayed, and the real DNS server responds quicker than DNS spoof package. So I will show you this from Windows. From Windows, it works. I'm going to attacker machine. I'm going to Kane. Perform this attack, you need to understand what you're spoofing in between what machines. Say you navigate to www.facebook.com on Windows 8. Would you please tell me what host needs to be ERP spoofed to perform DNS spoofing attack? Which hosts? You're connected to this LAN network from attacker machine. What hosts you will spoof?
I would say victim and domain controller.
That's correct. You spoof between DNS client and DNS server, not between router and the client. No. Could be sometimes you could spoof between DNS server and the internet. Yes. Could be you may spoof between this DNS server and internet as well. Yes. But in this case, I will spoof between DNS client and DNS server. So APR, remove, add 208, and say Windows 8, okay, go, and then switch to APR DNS. Add records, say facebook.com to point to your Kali 172.20.100. And one more option, www.facebook.com to also point to Kali 172.20.100. Please note that those names are different. This is not any the same word, not any the same name, not any the same IP address in real life. So this is not the same. And when user types in just simply facebook.com, it actually is redirected by web server or by DNS server to 3W. That this is additional operation of redirection. So taking this into account, I will spoof both names. So I'm spoofing, names are configured. I'm going to victim machine. No, not victim, client machine, which is Windows 8. And in CMD, I will ping facebook.com. I think you don't need an additional explanation. You understand that Facebook.com, this one is spoofed to Kali with Kane. So sometimes I use both attacker machines, Windows, to run Kane in ERP DNS spoofing, and Kali to substitute some exploits. Well, could you please tell me if it works for you as well? Check it, test it. Maybe somebody needs assistance. Okay, I'll check what you're doing. Maybe somebody. Good. You need to perform spoofing, not simply entries. So you need to spoof between DNS server and DNS client. Double check. Click APR. The root. Click root. Yeah, that's wrong. Remove this one and add the DNS server. What's the DNS server in this network? That's the domain controller. So select 208 and select your victim. For example, 8. Go and spoof. Now poisoning works. DNS entries added from victim machine, from client machine, Windows 8. Ping. No, Facebook.com. Brilliant. Oh, well, I'll go back to material. So that was one example of DNS poisoning techniques, because one more technique is to trick DNS server, not DNS client. That's another thing. So this could be your homework. My recommendation still the same. Only perform name resolution from your domain controllers on all devices, all domain members, all non-domain members, any devices. Only via domain controller DNS. Also, if you run, if you have, say, external DNS names such as Windows and TLV, for your Active Directory and external network, go split brain DNS. So register your domain on Cloudflare and the same domain on your Active Directory, but with different records. Use encryption such as SSL, IPsec for the traffic where possible. DNSSEC and SPF and other countermeasures are required for DNS in the real world. Do not allow DNS requests firewall. The firewall needs to set that only DNS requests may come to the real world from the service, not DNS clients. Well, ideas. Yes, this is bullshit. Recursion. Let me discuss what is this. I hope you know a little bit how world DNS system works, but no, I guess no. So this is your DNS client, such as just simply client. This is your local DNS server. And it runs some zones, maybe, such as CEHv13, such as Windows in TLV or whatever. There is the world system, DNS name system, and the root of this system is dot. Let me mark it with double quotes. This is dot. That's the root of everything. And actually, all the DNS names contain this dot at the end. It's here, it's here. So this dot exists. You do not type it, but it exists. So, and there are some root servers in the world which control dot, and they are called root hints or root servers. In many cases, when the client tries to ping facebook.com or maybe something more complicated, such as you type ping www Europe facebook.com, for instance, you go to your local server, but this local server is not authoritative for the zone. So this local server may forward the request to root hints, and the type of request you send to your local DNS is called recursive query. You send a request, you want your answer, nothing else, you want your answer. Then DNS server, which forwards the request to root, it sends the iterative query. It could perform iterations. Root hints may respond back. We don't know the IP address, but we know where to ask. So they forward you. Go to somewhere, to a server which controls zone com. It's not a single server, just simply one of servers which control com. To some other server which controls zone Facebook. And then the next iteration, you may ask this DNS server if it knows what is www.facebook.com. It could be one more iteration, could be one more step, could be just simply response that www.facebook.com equals 1, 2, 3, 4. So after all iterations, the recursive query is responded back to client. So if your DNS server allows connections from internet, from outside world, you need to disable recursive queries. Because as you might see, one single query may cause the whole set of queries across the network by this multiplying traffic. And this attack is called DNS amplification. How DNS amplification works? There is some victim, unsuspecting victim. You go to internet authorities and register DNS name that points to this IP address as name server for say bullshit.com. And then attacker navigates to zombie server. This is zombie DNS, which has recursive queries enabled from outside world, because DNS clients go with recursive query. And it asks for name resolution of 3w bullshit.com. And then this DNS server may send multiple requests to this IP address trying to perform name resolution. If you have several servers, DNS zombies, you could query them and they all will forward your requests to victim IP address. Victim is unaware. Victim doesn't know that it is registered somewhere as DNS. But the amount of traffic you see, it's multiplied. So that's why you must disable recursive queries from outside world if you run open DNS server on premise. You could only perform recursive queries within your local subnet, or local network, not subnet. So that's the idea of this. This is bullshit. Once again, please pay attention to this slide. You will be asked on exam about filters. Filters like this. You will be presented some idea or screenshot, something, and you will need to select the right filters for Wireshark action. One more thing to test is TCP dump, which is a common TCP dump, which is command line tool switches. Please learn switches for TCP dump. I have no exercises for TCP dump in my checklist, but this is your homework. You will be asked on exam about TCP dump switches. Could be a good idea to install multiple different sniffing tools, because you will be asked on exam if you know them. You will not be presented something too complicated, but could be you will have a screenshot of a network packet. You will need to answer properly what is this packet about. But mostly when they ask about tools, it's just like simply if you know what is this or not. Countermeasures. Let me check how far we are. Yes, I can talk a little bit for 10 minutes about firewalls, and then after the break, we will configure IPsec policy. So let's discuss countermeasures against sniffing. Yes, restrict physical access to the network media, such as cabling, switching, and so on. It should not be exposed for public or for users. Yes, use encryption to protect information, which stands for SSL, IPsec, some other way of encryption, and so on. This is bullshit. It doesn't work. This is bullshit. Doesn't work. It just simply doesn't work. This one is disputable. What you see yesterday, I was talking about configured network protocols on your network cards. So that's the good idea to review your network card settings and figure out if there are protocols which you do not use. This is very disputable because in most network deployments I know, we cannot switch to IP version 6. We can run in parallel, yes, but not switch to, because most of applications only support IP version 4. There are very stupid applications which support only IP addresses. Some applications have hard-coded IP addresses. This is totally crazy, but they do it. Developers are stupid in this case. Anyway, talking about IP version 6, this should increase your security in some way, because IP version 6 has IPsec built-in. Okay, good. IP version 6, many tools are not hacking tools, are not designed for IP version 6. For example, Kane will not recognize IP version 6. But still, you cannot move your network completely, totally to IP version 6, I think. At least the most important service, no way. So I don't believe this is possible nowadays. Talk about this one. Use certificates for email. Very simple. If you go to Google, if you search for pictures such as Outlook, untrusted, certificate, pictures, and probably your users saw this many times. So in this case, the certificate was self-signed or expired. Question: what do you do if 1,000 users call IT support asking for this error? What does support do? Typically,
Switch off.
Excuse me?
Switch off the support for.
No, they say click yes. They say click yes, or maybe like this one, principal name is incorrect. Because when you're flooded with 1,000 calls, you just simply say click yes. Because Exchange admin is unavailable. For example, during this week, I'm offline. I'm not at my company. And if I have missed my certificate on Exchange server, I don't know. I will answer my users, click yes. So this is the totally available attack vector for hacker. If users were instructed only one time to click yes, they will continue doing this. So I'm talking about incident management, same as on the day one. Yes, that's for sure. No HTTP. But you see, it's much easier to say and much harder to implement. I have, for some company I work for, we have a cloud processing system which is totally based on HTTP with hard-coded IP addresses. And it seems impossible to change anything because developers are like, they could agree with you like, yeah, this is wrong. Yeah, we will not do this again. And they do it again and again and again. This is bullshit. That's not about sniffing. Bullshit. Could be interesting. You see, there are tools which could detect if some network card runs in promiscuous mode. Promiscuous mode is always suspicious part. But you see, this is your homework. You will read how to do this.
And Peter,
Hmm.
Can you mention some of these tools?
Oh yes.
Just for example.
Just for example, I have it even in my checklist. Let's see. Let me see. A second. Yeah. XARP. And which detects ERP spoofing attacks. And from query UI. Query UI. I have used those tools. Let me check if I have it in my list, in my tools. But those tools, I have used both. Maybe we will find XARP in tools. Let me check. So CH client, Peter tools, no. CH tools, sniffing, detection. Yeah, XARP. Just simply run it. Yeah, on client machine. Let's see how it works. Run. Go. Run. So okay, X is running. And basically, yes, look at this. I'm sniffing, and it tells you that those IP address could be spoofed. Which one? That's the good question. But there's the alert and 3 suspected computers. So I'll close this, okay. And in a few seconds, it will pop up once again. I could do what? I can stop attack and run attack again. And you see the pop-up comes again. So MAC address for IP address has changed. But I have not tested this tool for, say, hundreds of PCs. Maybe I have one more tool. Let me check. Sniffing detection. Not this one. No. Sniffing tools. No. No. So I don't see from query. In this set of tools. It was in. Let me show you. Where is it? Let me show you. I'm going to my physical machine. I'm going to C drive, CH tools. So you could download this set of tools from me. It's quite big. And it has prompt query. Well, Google, what is this? And it works like you select the IP address range such as 192.20.1-254, and it tries to connect to every IP address and then says like, this NIC is in promiscuous mode, like this. All right, let's talk about firewalls a little bit. I need Notepad for that. You probably know basic firewall rules, which work on layer 3, not necessarily, okay, layer 4, not necessarily stateful firewall. We'll take stateless firewall. Very simple. So could you please describe to me what is the traffic of web client? What traffics should be allowed for a web client? I will give you the idea how to answer, such as HTTPS, HTTP, what else should be allowed for web client?
HTTPS.
HTTPS outgoing. That's correct, because this is different kind of traffic. Anything else?
DNS to
That's
our
correct. DNS outgoing. And basically that's it. Talking about mail clients. What kind of traffic could be allowed for mail client?
SMTP POP3
SMTP outgoing, POP3 outgoing, right?
IMAP.
Not
Could be-
outgoing, probably.
Could be IMAP outgoing, and what? It's not
Shouldn't-
incoming. It's not incoming, it's outgoing. Outgoing, I mean, you generate this traffic and send to a server. Server takes incoming traffic. What else?
DNS.
DNS. You're quite clever group, I'd say. Then, okay, the last one. Mail server. What could it be? Obviously, all the traffic supported by a client, but incoming. SMTP incoming. Oops. Next, POP3 incoming. IMAP for incoming. What else should be allowed on email server? On simple email server. Could be HTTP as well, why not? So HTTP as incoming for sure. This HTTP incoming? I think yes. Why? To have redirection to HTTPS. Anything else, please?
SMTP outgoing.
That's correct. SMTP outgoing. Sure. Anything else?
DNS outgoing.
DNS outgoing. That's for sure. Maybe RDP incoming. Because you need to have a manageable configuration. Maybe. SMB, if this is domain member, how do you authenticate users? If it has domain authentication, it should be SMB outgoing. If this is the domain member, yeah, SMB outgoing as well. That's enough. As you might see, quite a lot of traffic. Let's expand a little bit about words, how it looks like in traffic. What is HTTP outgoing in my language? It's going to be localhost from dynamic port issues traffic to say any 80 transfer protocol TCP. Does it look some intelligent to you? Does it make sense? Yeah. Okay. So any from port 80 can respond back to localhost port any with TCP. So you need to have both requests and responses. Exactly what you see in MikroTik. If you go to Victim Machine, where's my Victim Machine? I don't see my Victim Machine. If you go to MikroTik, oh, thank you very much. I need to drop it to program files because running from desktop is a bad idea. So if you go to no. Okay, look at this. If you go to IP firewall, you will see exactly this. So source destination one way, source destination the other way, transfer protocol port number for this protocol, and so on. I have just simply switched TCP and ports in this case. Okay, this is very the same, such as localhost any destined to any 443 transfer protocol TCP. This is good. Talking about DNS outgoing, so localhost from dynamic port comes to any 253 UDP, and responses come back from any 53 to localhost any using UDP. You can make it a little bit more complicated with your DNS service, not just simply any. But in general, this describes how web client works. To simplify this a little bit, just a little bit, I will do what? I will use IPsec language. I will say mirrored, and don't need the second part. It's not MikroTik language. This is a Windows IPsec language. Well, now the same could import mails. So say you could throw and you could visualize it. How I do this. Top. I type traffic. Could be HTTP out, or maybe you could summarize it as web client traffic, or maybe DNS out. Okay, it'll be like this. This is a Windows Active Directory member. So yeah, SMB out. TCP. What else? RDP in, because domain admin connects to this workstation. Not admin, okay. Support guys connect to this workstation using remote assistance. And any. And on the bottom, you could describe possible actions. What possible actions could be? Such as permit and deny. Or this could be allow, block, anything. So the basic firewall could look like this. Permit, deny. Does it look good to you? In general, yes. Some advanced firewalls may have more options. Which options could be? Could you please help me?
Drop.
Drop is the same as deny. No?
Maybe some log.
Log, that's correct. And if you run snort, alert. So HTTP out could be just simply permitted, DNS out could be locked and permitted, locked and dropped as well. Yeah, so this could be the combination of both. ICMP just simply permitted, RDP alerted, and SMB out, I don't know, permitted or locked just for fun, and anything else denied. Now this is a bit more advanced firewall, right? And IPsec firewall is even more complicated. And I'll be ready to discuss this after the break, because this may take significant time. So let's have coffee break, okay? Is it a good time?
Okay.
All right. So see you 10:30. Oh, no. See you at 11.
See you.
Let's continue. If you're ready. Yeah, okay, go. Well, so back to IPsec firewall. So we've got some set of filters. That'd be 5. 2 possible actions in here, and the IPsec represents 2 more possible actions. So say this is going to be mail traffic or mail out. Say this is going to be web outgoing traffic. Say this can be RDP incoming, SMB outgoing, and everything else just like any. ICP is not included. I don't care about. So possible actions could be such as allow or permit, such as deny or drop or block. And IPsec represents Windows IPsec via group policies. It represents 2 more actions such as encrypt and sign. So you could just like allow outgoing web traffic, block everything else because we run whitelisting, encrypt outgoing SMB, requires signature for incoming RDP, and say encrypt outgoing mail, just for instance. Maybe permit ICMP and so on. Well, the question is, where is that encryption implemented in signature, and how do you decide if you need to encrypt or sign? As you might imagine, encryption requires more processing power. Signature requires less power and less additional traffic. Maybe. Okay, so encryption, I'd say encryption requires more resources. Signature doesn't require to encrypt the traffic, but it needs to be authenticated. Why I have selected this way, like RDP signed. The task could be like only allow RDP from, say, AD joined hosts. So you could issue the certificate on the computer, and computer will be authenticated via this certificate and sign this this protocol. Modern RDP is encrypted and it does not require additional encryption on top. So you don't need to encrypt this traffic twice. But signature could be used to authenticate the source of the connection. In contrast, SMB could be encrypted. There is one more thing to discuss, is like when you send anything encrypted by using some encryption key, how the receiving party could decrypt the message. So you need to exchange this data in some way. I'd say in this case, both SMB server and SMB client must be configured and enabled for this type of encryption. So, from one side, one point of view, the firewall, IPsec firewall is like firewall. From the second point of view, you need to configure both sides to make encryption happen or signature happen. And one more thing to discuss is like you encrypt or sign using 3 possible options. First option is Kerberos. The second option is a certificate. And the last option is the passphrase. So if you connect to some host which requires signature with Kerberos, but you sign your traffic with password, this will not work. So both parties must be configured in order to synchronize their type of security and type of key utilized for signature or encryption. And what you see at the top is called IP filter lists. At the bottom, filter actions. And in between all those arrows, actually build an IPsec policy. So when we go to configure IPsec policy with our virtual machines, you will need to configure IP filter lists, filter actions, and then you will be able to build a policy. So this is what I'm going to do with simple IPsec policy with two virtual machines, say domain controller and the client, and say I will encrypt RDP traffic, and on server, RDP server, I will require encryption. Yeah, so one more thing to discuss is optional or enforced. So encryption could be enforced or could be optional. And the schema would be like this. This is RDP server. It will require encryption. Set encryption. Enforced with a password. At the same time, the client will have the policy of outgoing RDP. So this is RDP in, and this is RDP out. Encryption, optional, with the password. So the client will be able to communicate to other RDP service as well, not only this one. But this one will only accept forcibly encrypted encryption. So that's the idea. To achieve this, I'm going to RDP server maybe. Which one? You know what? I will not touch the domain controller because it also plays another role such as DNS, DHCP. I will configure web, this one, 2012, because it only hosts web. So I will have the following rules. Web and ICMP permit any log. So this is going to be strict requirement for web server. To configure policy, I'm going to GP edit MSC. To computer configuration, Windows settings, security settings, and IPsec policies. Right-click, manage filter lists and filter actions. And to make it clear, once again, I will drop it to Notepad. What is web in? What is RDP in? What is ICMP? And what is any? Incoming web is when any from dynamic port connects to my machine, the local host, to port 80 by using transport protocol TCP, and this is going to be permitted, mirrored. incoming RDP from other machines is the traffic initiated from dynamic source dynamic port to my machine, to localhost port 3389, transport protocol TCP 617 UDP mirrored, and this should be an encrypted enforced with the password. ICMP, source any, destination any, transport protocol ICMP permit. And any stands for any protocol, any could be blocked. If you check the firewall of MikroTik, you will see that it has the preference of sequence, such as rule number 0, 1, 2, 3, 4, and so on. And rules work from top to the bottom, one by one. In contrast, IPsec works by best match. So basically, any which is blocked also covers ICMP, which is permitted. But if you ping this machine, this rule is the best match for pinging, so it will be permitted. And there is no rule sequence like 1, 2, 3, 4, 5 in IPsec policy. Well, so I begin describing IP filters. Right-click, manage IP filter lists, and add filter list. First N is incoming web, web N. It only consists of a single rule, maybe two rules, yeah, HTTPS as well. So rules will be mirrored. Source, any computer from any network. Destination, my computer. Transport protocol, TCP, 6. From dynamic port to my port 80. Frankly, that's not the only traffic of web. I will add 443 as well. Add. Mirrored rules. Source, any IP address. Destination, my IP address, localhost. Transport protocol, TCP. From dynamic port to port 443. One more rule which describes web traffic is ready. So I will add it like this. This is also web in. And this is 443. Good. Okay. One more filter. Incoming RDP. RDP N. Well, mirrored rule, that's okay. Source IP address, any. Destination, my computer. Transport protocol, TCP. From dynamic port to port 3389. Ready. Now I remember that beginning Windows Server 2012, RDP may have one more traffic type, which is based on UDP. So I will add UDP rule to this filter as well. One more rule, mirrored, source any, destination localhost, transport protocol. It's not RDP. It's not reliable datagram protocol. It's UDP. 17 from dynamic port to port 3389. Yeah, it's ready. So I have described two filters, this one and this one. Now I will add ICMP to allow pings and any. ICMP is very simple. So as the filter adds mirrored, source any, destination any, transport protocol ICMP. And it's done. There are no ports in ICMP. And one more, the last one. Filter is any. So any, which is defined as any, done. Okay, so what I have achieved, I have described all possible IP filters, such as incoming web, incoming RDP, ICMP any direction, and any other traffic. So it's done for the top of this picture. Now the bottom of this picture, actions. Switching to actions, and there will be 3 actions, such as permit, block, and encrypt enforced. Okay, good. So first action is permit. And this is just simply permit. One more possible action is block. And the selection is quite simple, block. And the last one, which is the most complicated, is encrypt, enforced. And then I select negotiate security. Okay, let's talk about security with the sending party. And the first question is, will I allow unsecured communication? There are 3 possible types of IPsec communication between computers. First, IPsec capable, configured. The second one is IPsec capable, unconfigured. And the third one, IPsec incapable. And those are totally different things. I will only accept connections from IPsec capable PCs configured with specific policy. So I will not allow unsecured communications if IPsec could not be negotiated, because this is strict requirement for this RDP. Next. And this choice describes the difference between encryption and signature. You could also customize this. And I tell you what, you may be asked on exam on supported algorithm types. First, let me describe the first concept which will be present on exam. When you configure 2 hosts, such as the server and the client, and enable secure communication via IPsec in a tunnel like this. Just simply IPsec, not tunnel, but synthetic tunnel. This is called transport mode. In contrast, the tunnel mode, real tunnel mode, is established between subnets. So you have subnet, you have subnet, you have border router of Windows Server like this, and you configure IPsec between border routers, and this is tunnel mode. We currently are running transport mode in this demo, not tunnel mode. Okay. Second, what you could be asked is like difference between integrity and encryption. Integrity utilizes authentication header algorithm and encapsulated security payload. Authentication header based on hashes. That's why you see SHA and MD5 in here. It's hashing, it's signature. Encapsulated security mode includes encryption, symmetric encryption. which is enabled by DES3DES. Again, you may be asked on exam about what algorithm is used for, say, signature or encryption, and what specific encryption algorithm is utilized in ESP, and what specific algorithm is utilized in authentication header. So please pay attention to this. And demo, I just simply select integrity and encryption. So authentication header with SHA-1 will be used, and ESP with 3DES will be used. So I have created, by this I have created possible actions. So filters, actions, and now it's time to build arrows. Right-click, create IPsec policy. Unfortunately, you could only activate one policy of multiple policies. If you create 10 policies, unfortunately, they are not summed. So you need to describe in a single policy everything about this PC. Okay, so this one is a secure web server. Default response rule tries to apply some action if the descending party tries IPsec to you and you don't know what to do. I will not use default response rule anyway. So this is empty policy, which does nothing. And the default rule is not enabled. I will create my own rules. First rule is to allow web. This is not a tunnel, not tunneling mode. This is transport mode between two hosts. I will encrypt all network connections, yes. So incoming web traffic, I will permit. So the first rule is done. Incoming web is permitted. One more rule to permit ICMP. This is not a tunnel. All connections, ICMP, permit, finish, done. Next, I will block everything else. This is not a tunnel. All connections, any, block, done. And the last rule, which is most important, is to encrypt incoming RDP. So adding rule, not a tunnel, all connections, incoming RDP must be forcibly encrypted. And the next question, encrypted using what? I cannot utilize Kerberos because this is not the main member. I cannot utilize certificate because I don't have CA in this network. I will use password. Go. And double checking this rule. Let me check. Yeah. So I will not fall back to unsecured communication in any scenario. Okay, good. So rules are done. 4 types of traffic, 3 types of actions. Okay. Basically, I can do what? Right-click, assign. From now on, only IPsec encrypted RGP connections are accepted to this machine. Let me check if RGP is enabled. Yes, RDP is enabled. It could be NLA or whatever, I don't care, because it's encrypted on top with IPsec. That's not enough. I need a client clients also need to be configured. Okay, I'm going to a client such as this one, Windows 8, and configure GPEdit MSC. This is also not a domain member, so I will not deploy it via domain group policies, just a local policy. IP security policies. And also need to describe rules. So this will be very compatible client, such as just for the purpose of RDP. RDP out, which is my computer from dynamic port initiates connection to any 3389 by using transport protocol TCP mirrored should be encrypted. Optional, because I need to connect from this client to both secure and insecure servers, encrypted with a password. Also, I will add UDP, because UDP is also one possible option for RDP beginning Windows 8. I need to take this into account. And say any permit. That's enough. I don't need to block anything on client side or any more actions. So this is not whitelist firewall, just simply encrypt RGP when required, and this is it. So 2 simple rules. Right-click, manage filter lists. So first filter is outgoing RDP. And I will add 2 traffics. First one is mirrored from my computer to any computer by using transport protocol TCP, and from my dynamic port to port 3389. Okay. One more traffic needs to take into account UDP. So adding one more rule to this filter, mirrored. I initiate the connection to any IP address by using UDP protocol from dynamic port to port 3389. Finish him. So outgoing RDP is described by 2 rules, and everything is good. I will add any just to clearly define that everything else is allowed. Source any, destination any, protocol any. This is it. Okay, so 2 filters are defined: outgoing RDP and anything else. Now actions. So this is done, this is done. Possible actions: optional encryption and permit. First action is very simple: permit. And I select permit. The second action is a little bit more tricky, and this is encrypt. Optional. We need to talk about security, discuss security, yes. Allow unsecure communication, because I will only establish secure communication to that specific server, and I will be able to communicate to other insecure servers as well. Both integrity and encryption, that's okay. Good. So 2 actions, 2 filters, 2 actions. Now I'm putting arrows between filters and actions. And arrows is actually IPsec policy. Go. This policy could be called compatible RDP client. Go. No default response rule, whatever. And I'm building 2 rules, 2 arrows. The first arrow is, this is not a tunnel. All connections. Outgoing RDP could be encrypted based on password and the same password. I cannot select Active Directory because the receiving party is configured for password. I cannot choose another password because this password should be shared between parties. And the second rule is not a must, but I will just simply add it to see directly clearly that it works. So for all connections, all other traffic is directly permitted. Okay, and this policy is assigned. Well, so this IPsec is running. IPsec is running. Time for Wireshark. Sniffing Ethernet. Next, I will try to establish connection to that remote RDP server. 10.20.0 to 12, go and stop. Connection is established. It works. But how actually this traffic looks like? And let me describe what you see in here. This one is not the question, this one. You have two incoming packets from client to the server. The first packet is unsecured connection with SYN flag to port 3389. The second one is an attempt to synchronize keys, key management process. So the client, since it's compatible, it has sent two packets simultaneously, secure and unsecure. As you might see, the server responded back with ISA KMP protocol, so unsecured connection was simply dropped, and the security association was established. For this, they utilized UDP protocol 500 to 500, IPsec to IPsec. After key synchronizing, you see encapsulated security payload, which is actually IPsec traffic. And the only thing which we can understand that the communication takes place between this IP address and that IP address. What's inside, we don't know. Should it be RDP, SMTP, SNMP, whatever, we don't know. We can only guess by looking at first packet, because the client is compatible. If there were no such packet, just simply key synchronizing and ESP, and this is it. And what they are talking about, we don't know. Well, this is it for this configuration. I'm deconfiguring group policy. So policies are removed. And let me check the material. This material will be discussed a little bit later in session hijacking module. You will see IPsec description. Please just simply pay attention to those slides, because you'll be asked on exam. Next module, let me check after IPsec. Oh yeah, I might forgot that we are hackers, right? Yeah. So the question is, can we hack into this IPsec conversation? And the answer is, I cannot hack into IPsec protocol, but I can hack group policy. This group policy is stored somewhere locally, and domain admin is able to to see the domain group policies. Local admin is able to see the configuration of group policy. You go to where is my password? Where's my password? Encrypt and force it, yes, but is it the authentication? Yeah, you see, the password is not hidden behind asterisk or dots in here, so local admin can read the state of the policy. And where is it kept? If you run regedit, if you go to software, Microsoft, Windows, software, Microsoft policies, Microsoft, Windows, IPsec. So it's kept in registry in here, policy. That's the IPsec policy. And somewhere here, you will find in NFA IPsec data something interesting, such as, for example, password. This one in clear text. If you say, okay, everybody is able to read this file, basically system and administrators can access this register key. So if you have unrestricted physical access to a computer, or you have escalated privileges on a client computer, because the password is the same on both server and the client. So if you can hack into a client, you may find this password in clear text in registry. One more way to find this password is domain group policy. If you configure this GPO and GPO arrives to your computer, let me check GPO cache on victim, because victim is the domain member. And if you go to, on Windows 7, it was program data Microsoft group policy, program data Microsoft group policy history. Yes, that's on Windows 7. You will see the history of group policies arrived to this machine. Even if you delete this policy from the main controller, or on the main controller, you may do what? You select some group policy, like this. You select, say, computer policy, and change permissions from authenticated users to domain computers. So users will not be able to read this GPO, only computers, but still it will be cached on client side, and you will be able to get to the content of this group policy as local admin, and sometimes as the user. As you might see, everyone on the computer is permitted to read this folder. So even if on the main controller group policies are secured from reading, you may find them in local cache in history. And sometimes it happens to find the passwords, IPsec configuration, and so on. So that was very simple hacking of password. One more way to hack IPsec based on certificates. Let me show you an example on web server. I'm going to IIS, Internet Information Services. As you might see, there is the certificate in this server, because I have issued this certificate for HTTPS. We can do one more thing, an MMC console. and remove snap and certificates for computer account. So this certificate together with a private key, and you see this by icon. So icon shows you that private key exists on this machine. It's here. You have private key. It could be marked as non-exportable. So if you right click all tasks export, in this case, I will be able to export the private key. So I can steal the certificate from server side, from client side. Okay, in this case, I'm not stealing. I'm preparing it to be imported without permission to export. So in the desktop, let me drop it as CEHv. Okay. I have exported it and delete. So I have some specific certificate on this computer. It's not necessary to be web, just simply certificate. If I install this certificate to local machine and then select this option, so this key will not be exportable. I'm placing this to personal store. Finish. Okay, so again, this web server has the certificate with private key, and it's not exportable. All tasks, export, next, and you see from now on, I have no permission to export the key. An attacker still can export the key by using certificate jailbreak. Let me show you an idea of jailbreaking. So this console will be saved to the desktop and say certificates MSC. Desktop, yes. Okay, good. Next, I go to Peter Tools. In Peter Tools, I navigate to password dumping folder, and there is certificate jailbreak module. I will drop it to the desktop as well, maybe. Let me check my checklist for this one. Yes, I will modify this batch file to point to my certificates console. Okay. Paste. Certificates MSC. That's correct. Save. Go. Now I have two consoles open. This console running as admin, and I cannot export the certificate together as private key. And this console is jailbreaked. Right click, all tasks, export, and now I have the possibility to export the private key. So the purpose of this demo was to show you that non-exportable certificates still cannot be exported from a computer. An attacker can export certificate of a workstation, of a server. It's not necessary to be web certificate. This could be Active Directory issue certificate of a computer. Maybe Active Directory certificate of a user, such as domain admin. So attacker may export the certificate of this security subject and utilize on their PC. Even if IPsec is based on certificates, you could steal the certificate, apply to your attacker machine, and use IPsec to connect to sensitive services. Any questions so far, please? I think that was a little bit complicated, right? A little bit. Well, need to have some experience with firewalls and group policies. I'm going to the next module. The next module is social engineering. Let's check quickly what interesting we have in here. And what specific attack I have for social engineering in here. You know what? I will skip it at the moment. I suggest you reading those slides at home, because you may be asked on exam on some kind of attack types. I'm quite sure you will be asked on an exam about this. So please read this module carefully, and slides like this, check them carefully at home. Yes, now I remember I was asked by on exam for what is wishing, what is smishing. No, not this one, but that one. Smishing, for example, SMS. I don't know what they will ask you about artificial intelligence-based social engineering attacks. I don't know. Just still, please read about this in material. Denial of service is more technical module, so I have a few exercises prepared for you about denial of service. Let me describe the difference between denial of service and distributed denial of service, because they show it as denial of service. This is not true. This is what you see on the picture, distributed denial of service. So malicious traffic from multiple sources is exhausting the capabilities of network, CPU resources, memory resources, disks, and so on. So in this case, this is distributed denial of service because of many connections from many sources. In contrast, simple denial of service is when you make a click and your victim dies. This is also some part of hacking. It's not necessary to hack passwords. It's not necessary to steal business data to render your victim unusable, useless, or to kill the business. It's enough to disconnect it from the network. You know, just simply cut the cable with scissors. This is also hacking attack, which blocks business from working. So let me show you simple example of what could it look like denial of service. A second, I'm checking my checklist. Yes, I have an example of denial of service. Please go to the main controller. And the main controller, you don't need to close anything. just simply go to command line and type the following command. Make directory C $MFT /AAA or whatever, blah, blah, blah. So create a folder in the root of the C drive, which is something inside $MFT. And the error message is good one. I don't care. I know that I have already killed my domain controller. You could count till 10. Try opening some computer, maybe consoles, such as computer management. I have double-clicked computer management and nothing. I'm trying to run MMC and mount Active Directory users and computers. Let me check. And I see clock, and it works. Something works. Still works, maybe. GPMC, okay, it works, but it might take few minutes and applications will stop working now. Firefox locked up and doesn't work anymore. Some executables still running, but Firefox already died. Computer management is not opening, and in a few minutes Windows Server will just simply lock up and die. Does it work for you, please? Okay, good.
Yeah,
Works for you? So basically, it does nothing. You cannot control this computer anymore. And you cannot even reboot. You need to reset. Machine reset. That's the only response. Then this type of attack is called nuke. Not switching language. Nuke. So nuking your target, nuking your victim, means to send some specific packet, which performs denial of service on the target machine, such as disconnects from the network, or kills CPU processors, or fills up the memory, and so on. So this is nuking. How could you apply this nuke for 2008? There are plenty of ways. What if we have a share? Say we have shared, say B drive shared as data. So on the client machine, you could navigate to $CHDC/data/$MFT/BBB. So you could kill this server remotely via SMB. Or do you remember yesterday I was talking about file.library.ms? So you could inject a tag into this file, which points to some local disk $MFT. Or one more example, if you navigate to some 3W attacker.com and there's the tag HTML tag image source equals $MFT/ego.jpg. So in case HTML contains this expression, by simply navigating to this website, this operating system will stop working, will be nuked. Let's check one more, a little bit more complicated nuking from the network. Please go to Windows Victim and make sure RDP is enabled. So right-click System Properties, Remote Desktop. Which version, less secure or more secure, I don't remember. I will test with less secure, but I think it doesn't matter. So just make sure RDP is enabled and we go to Kali. We will attack Windows 7 from Kali. On Kali machine, run MSF console.